All right, guys, here we go. Review for test 21. The first one's take the domain range and asymptote and graph that function. E, just like any other exponential function, pretty much graph the same. It's bigger than 1. E is like 2.71828, so it's actually a exponential growth. Asymptote's down at -2. I'm going to go up 1, but left 3 because of that plus 3. I'm going to go 1 to the right there, and I will get e to the 4th minus 2. I'm going to punch that value in my calculator. All right, when I punched in -2 in for x right there, it gives me e to the 1st minus 2, which gives me 0.718, which is almost a positive 1 right there. So I plugged in -2, got about positive 7.1. Graphs can do this, like exponential growth. Domain is left and right forever, is all reals. The range is, it's going from -2 up forever, and the asymptote is also y equals -2. Don't forget your y equals on your asymptote. Number 2. Population of certain species of birds is much about type of habitat. Population behaves according to this growth model, where t is measured in years. Find the initial bird population times 0. So if I put 0 right there, and for that x, and for that t, sorry, the e basically turns into 1. So the denominator becomes 0.5 plus 27.5, which is 28. So I'm basically punching in 5,600 divided by 28, which is giving me 200. So at the initial bird population is 200. What is it after 3 years? All right, so I'm going to plug 3 in there and see what I get here. And I punch all that in. I'm getting 713.719. So you don't really round birds. So we'll say, okay, there's 713 birds. Now, I'm going to be honest with you. I don't have my graphing TI-84 here at home, so I'm using an online calculator. So if that's not correct, well, I'm sure you'll correct me. But just plugging 3 in there. Make sure you use parentheses around the whole denominator. Should be good. All right, a radioactive substance decays in such a way that the amount of mass remaining after t days is given by this function, where m is measured in kilograms. Find the mass at time 0. So again, plugging 0 right here for the exponent, which make sure exponent 0. E to the 0 is really 1. So the mass at time 0 is 6. Now, at 20 days, I'm going to punch this in. I'm just going to plug, let me see if I can get this right. I'm going to plug 20 in for the t in the exponent and see what I get. When I punch that in, I'm getting 1.05. What is that? Kilograms left. Of course, that first answer should be kilograms also. Because the negative exponent obviously makes it decay, so it is decaying as time goes on. All right, number 4. If 6,500 is invested at a rate of 7.25%, compounded continuously, find them out after 12 years. So that means I'm using PERT, P-E to the RT power. So if I plug those in, remember P is principal, what you start with. E, the rate, is 0.0725 times 12 is going to be my exponent there. So I'm going to punch it in, see what happens. And I'm getting, let's see, $15,514.92. Now, we'll say this about these answers. Again, I'm going to remind you, I don't have my TI-84, so I'm using an online calculator, and it could be just a little bit off, but it should be pretty close to that right there. So hopefully that looks good. All right, number 5 and 6, graph these exponential functions. These are actually reviews. The first one is a 2. Well, f of x equals 2 to the x minus 3 power. No shifts at all as far as up and down, so the asymptote is right here at x equals 0. The first point is you go up 1. I got a -3, which means I'm moving it right 3. To get my second point, I'm going to plug in 1 to the right, which is 4. 4 minus 3 is 1. 2 to the first power is 2. Get this right here. There's my graph. Make sure you show both points. Domain, all reals, range, 0 to infinity, the asymptote, y equals 0. Number 6, I'm going to change it around. That negative exponent, negative x makes that really a positive 3 to the x power minus 2, which is growth again. There's a -2 though, which shifts the asymptote down 2. The first point's going to be, actually there's a negative in the front, so instead of going up 1, I'm going to go down 1. Plug in 1 to the right, which would be +1, which would give me -3 minus 2, which is -5, which is right down here. And there I go. Again, domain, all reals, the range, -infinity up to -2, and the asymptote is at y is -2. Number 7, a certain breed of mouse introduced on an island with an initial population of 250 mice, and scientists estimate that the mouse population is doubling every year. Okay, this is also a review from last week. The function, remember, this is YART. Looks just like this right here. y equals AR to the T power. So part A, I'm just going to plug it in. The initial population is 250. It's doubling. So I'm going to put a 2 here. The time is T. That's part A. The B, you just got to plug in the 8. So I'm going to plug in an 8 right there. What that exponent is, I'm going to punch in 250 times 2 to the 8th power. Having done that, I'm in 64,000 mice, which is way too many. All right, number 8, investments. This is also a review. This is compound interest. An investment of 8,000 is invested at a rate of 4%, compounded quarterly. So I got $8,000, compounded 4%. Quarterly is 4 times a year. My exponent's n times t, which is 4 times 7. Putting 28 right there. Gonna punch that in real quick. Punch it in, I'm getting 10,570 and 33 cents. And again, please check these because again, I'm using online calculator. Number 9, what would the value of investment number 8 be if the interest rate was 3.6 compound semi-annually after 9 years? So same deal, same numbers, different rate. Semi-annually is 2. 9 years, 9 times 2 is 18. My exponent's 18. And again, give me a sec to punch that in. And I'm getting $11,029.35. All right. Number 10, express this in log form. I'm going to go 8. Remember how this works. It goes this way. It really goes 8 to the 2/3 power equals 4. Here, what you write should be true. You should be able to check that on your calculator or something. Second one, write in log form. The base over here is the base over here. So it's base 81. Remember, the answer is the exponent. The answer to a log is the exponent. So the exponent is the answer. Number 12. Basically asking me 4 to what power is 64? 4 to the 3rd power. Do not miss part B. 5 to what power is 5 to the 7th? Did you hear what I just said? 5 to what power is 5 to the 7th? The 7th power. And lastly, 5 to what power is 125? Really asking this right here. What would you do to 5? What exponent would you raise it to get 125? Well, first of all, you'd cube it to get to 125. But because it's been flipped, you have to have a negative exponent to flip it. And 13, sketch this graph. Before I do that, I'm going to factor the top and the bottom. I get x plus 2 over x minus 1. My denominator is x minus 3 over x plus 1. So my asymptote is my vertical asymptote. I have 2 of them, 3, negative 1. My horizontal asymptote, I'm looking at y equals 1 because leading over leading. X-intercepts what makes the numerator 0, which is negative 2 and 1. My y-intercept, just cover up all your x's, and that leaves you with 2/3. So I'm going to graph what I have here. The vertical is x is 3, which is right there. Also x is negative 1, which is right there. Horizontal is y equals 1, which is right there. My x-intercept's at negative 2 and 1, and my y-intercept is at 2/3. Y-intercept 2/3. So what I pretty much know just from those points right there, I know that my middle part's going right through here. I know the left-hand side has to be here. All I'm lacking is the right-hand side. So I'll punch that in, and when I do, I'll find out that it's in that region right there. That's 13. 2 more. 14, use synthetic substitution to find p of negative 2. And it says the remainder theorem. Hint, hint, it does say the remainder theorem, which means your answer is the remainder. All right, now, there's no exponents missing, so I can just go straight here. Going to do the synthetic really quick. Multiply, add, multiply, add, multiply, add. I'm getting negative 7, so my answer, P, if I plug in negative 2, I would get negative 7. Number 15, just divide. 1/2 goes in the box. I got a 2, a 0, a 3, a 0, and negative 1. Bring the 2 down. Half of 2 is 1. Add 1/2 times 1 is 1/2. If I add those, I get 7/2. Multiply these two. You just multiply the numerator and denominator. You get 7/4. Same thing. Multiply the numerators, it's 7. Multiply the denominators, that's 8. Negative 1 is really negative 8/8 plus 7/8 is negative 1/8 for my remainder. So don't forget to write your answer. 2x, start 1 degree less, 2x cubed plus x squared, 7/2 x plus 7/4. And remember the 1/8 is your remainder. So there you have it. All right, guys, hope that helps. Quite a few questions, quite a bit of review because we only had 2 days this week. Hope it helps, trying to keep you fresh for your final exam later. So hope it helps. Make a great grade tomorrow. See you then.